Hello, this is problem number 6 of section 1.1. I have everything written out already just because I felt it would be faster if we just discussed the problem, because this is a much more visual problem really than anything mathematical. The problem reads, in this section we discussed examples of ordinary everyday functions. Population is a function of time, postage cost is a function of weight, and water temperature is a function of time. Give 3 other examples of functions from everyday life that are described verbally. What can you say about the domain and range of each of your functions, and if possible, sketch a rough graph of each function. Number 1, I just chose savings over time, and so ideally, your savings would increase with every given year. Those sharp declines are maybe for some transactions that you make, or maybe paying mortgage or rent or utilities. I guess if we were to get incredibly technical, you could have, if we were to get extremely technical, maybe your graph would look like this, and there would be a closed circle and an open circle, and then a closed circle and an open circle. But for all intents and purposes, this is just showing that the general trend of savings does increase in a perfect world. And we can see here that the domain, well, x is greater than 0 because we can't have negative years. And with the range, we're going to assume that we don't go into debt, so y is going to be equal to 0. For number 2, velocity driving through a city. In the y direction, we have meters per second. And in the x direction, just time. And so again, we can't have negative time, so the domain is going to be x equal to or greater than 0. And for the range, we're also going to assume that we're not backing up at all, only speeding up and slowing down. So the velocity will be greater than or equal to 0 as well. And so as we can see, maybe if I choose a different color just to highlight some of this, you can see on this portion we're speeding up. We go at constant speed. Maybe we slow down a little and then speed up. There's a little traffic there. Then smooth roads, nice constant speed, and then you have a red light, very brief red light, you speed back up, and you go a slower speed than before. So that's kind of a verbal description of that function. Lastly, a little bit of an interesting one. Purchasing power of $1 since 1900. So what I mean by that is in 1900, if you had $1, you could get yourself maybe a 25th ounce of gold or 1 ounce of silver, or maybe you could get yourself several loaves of bread or a few dozen eggs. The idea is that even though wages have gone up, there has still been inflation, which means that a single dollar alone, just $1 by itself, holds less value than it did 100 years ago, or in this case, I guess 120 years ago. So I just have some arbitrary indicators in the y direction, 1, 2, 3, 4, and 5, and years in the x direction. Years since 1900, they're in intervals of 25 years. So the idea is that in 1900, you have the most purchasing power with $1, and then it decreases steadily over time. And that's mostly it with that. There's nothing too complicated with it. Just a simple graph showing the buying power of a single dollar over time. The reason it doesn't go to 0 is because right now the dollar still has value, and you can still get something for $1. So that's the reason why I don't have it going all the way to 0. That's the reason why the range here is greater than or equal to 1, because it's not completely worthless. So you can still get quite a lot with a dollar. So, well, or at least with dollars in general, right? Anyways, that's it for that one.